How to solve quadratic equation by extracting square root. There's a rule that we need to follow. That rule is square root principle. It basically states that if our x squared is equal to a and a must be greater than or equal to 0, then our a or our x here or our root has two possible answers. It can be positive or negative square root of that particular a. Okay, so it basically can be written as x equals square root of a or x equals negative square root of a. Whatever format do you want to write, you can use any of these two formats. Okay, so for example, if we have here x squared equals 25, and we all know that our a here is 25, right? Then we can write it as, we can use that principle. We have x equals plus or minus square root of 25. And we can simplify 25, right? Square root of 25, that is going to be 5. So there are two possible answers. It can be positive 5 or negative 5. Now, let's proceed to the following examples. So let us solve for x. If we have x squared equals 49, let us solve for x. So here, we follow the format already, and our a here is 49, and that is greater than 0, right? So we can use the square root principle. X equals plus or minus square root of a, which is 49. Okay, so we can simplify 49, right? Because 49 is a perfect square number. Okay, the answer would be x is equal to plus or minus square root of 49. That is going to be 7. And that should be our final root, final solution here. Okay, so now we have m squared plus 3 equals 51. The thing is, we need to make this particular format as this format. So for us to do that, we can subtract 3 both sides, leaving us m squared to the left side of our equation. Okay, 3 minus 3, that is 0. So we can cancel them. 51 minus 3, that is going to be 48. Okay, so 48 is our a, and that is greater than 0. The answer would be, or the m would be plus or minus square root of 48. But here's the question. Is 48 a perfect square number? No, it's not. So we can use this particular method. This is a tree method where we can use the prime numbers for us to factor 48. So 48 divided by 2, that is 24, right? So 24 divided by 2, 12. 12 divided by 2, we have 6. And 6 divided by 2, leaving us 3. It basically changes the 48 here, our radicand, as these prime numbers. Okay, how many 2? We have 1, 2, 3, 4. So 2, 2 times 2 times 2 times 2 times the other one, which is 3. Okay, that is m. Go ahead and check now if you want to verify. If you multiply these numbers here, the answer or the result must be the 48 itself. Okay, so we can even write it as 2, 2, 2, 2. There are 4 2's. We can write it as 2 raised to 4. Okay, and we have the remaining 3 here. So let us simplify the radicand here. As you can see, there's a rule here. If our exponent inside the radical symbol is greater than to our index, then we can simplify this. So as you can see, we have 4 as our exponent here, and our radicand of our square root is 2, right? 4 is greater than 2. Then the base here, the 2, will go outside. So I will draw a radical symbol here. The thing is, the 2 base here will go outside, and we divide the two exponents, or the exponent and the index. 4 divided by 2, go ahead, and the answer must be 2, right? So 4 divided by 2, that is 2. And the thing is, we have the remaining 3 here. What is the exponent of 3? That is 1. 1 is less than 2. So um, the 3 here would remain. Okay? And our final answer would be m equals plus or minus. We simplify 2 squared. That is that is 4. 4 square root of 3. And that should be your our final solution. It can be positive or negative 4 square root of 3. Now let's move on to the next one. So we have 4x squared minus 9 equals 71. And the thing is, we can transpose negative 9 to the right side of our equation by adding 9 both sides, leaving us 4x squared equals, this one is will be cancelled, 71 plus 9, that is 80. And then we divide both sides by 4 for us to eliminate or to isolate x squared here. So we have x squared 8 is equal to 80 divided by 4, that is 20. And then we apply the square root principle. So we have x equals plus or minus square root of 20. And 20 is not a perfect square number, so we can apply this 3 method. So 20 divided by the prime number 2, that is 10. 10 divided by 2, that is 5. Then we can even write square root of 20 as 2 times 2 times 5. That is equal to x. Okay, so we have 2 here. Okay, the 2 here can be written as 2 squared times 5. And that is equal to x. And finally, we have our index here, that is 2. We can also simplify 2, or we can also divide the exponent 2 here by 2. That will give us 1. So basically, we can write the 2 outsides of our radical symbol. Okay? And 2 divided by 2, that is going to be 1. Or we can write 2. So that will leave us a radical number that is 5. Okay, so the final answer would be x equals plus or minus 2 square root of 5. And now we have here the final given. We have the quantity of 5x minus 3 raised to 2 equals negative 32. So we have here the a would be negative number. So basically we cannot apply the squared principle, but let us try. So we can write 5x minus 3, that is equal to plus or minus square root of negative 32. Okay? So adding both sides by 3 will give us 5x. Okay, we can cancel this one, plus or minus square root of negative 32 plus 3. Okay, so dividing both sides by 5 to basically isolate x. And the final answer would be plus or minus the square root of negative 32 plus 3 over 5. Okay, so I just want to inform you that when you see a negative a, or a radicand that is negative number, so automatically our answer is already decided. Our answer is no real solution. It can be imaginary, but the answer is no real solution. Okay? If we see a negative a or a negative radicand. Okay? So, I want you to level up your skill and go ahead, get your notebook, try this and solve for X. Okay. So follow the process that was given here in a particular solutions and let your teacher know if you um, write the correct solution or process. Okay. See you in our next lesson.